So this is the Navier-Stokes equation for cylindrical coordinates. So again, please remember that we will use the idea of the capital D over dt, and it is equal of this term. And for polar coordinate, it is equal to del over del t plus ur del over del r plus u theta over r del over del theta plus uz del over dz. And this is nabla, and for nabla square here, it is equal to del square over del r square plus 1 over r del over del r plus 1 over r square del square over del theta square plus del square over del z square. So for polar coordinates here, I didn't show you how to derive the Navier-Stokes equation because the derivation is not in our syllabus, and the derivation is too long to be shown. So for our syllabus for fluid mechanics 2 here, so we omit the derivation of Navier-Stokes for polar coordinates, but you need to remember the Navier-Stokes equation for polar coordinates. So this is the final version, the final version, the final equation of Navier-Stokes equation for r-axis here. So it can be simplified, written as dur over dt minus u theta square over dr equal to gr, gravity minus 1 over rho del p over del r plus nu kinematic viscosity nabla square ur minus ur over r square plus 2 over r square del u theta over del theta here. And if you expand this term, you will get all of these terms. Okay, please be careful. The nu here is the kinematic viscosity, not the velocity. Please make sure the meaning of this symbol. Please be careful in your handwriting. And this is the Navier-Stokes for theta axis. So this is the simplified version, and this is the expanded version. So please be careful because the terms for polar coordinate is not remain the same, because it has slightly changes between r-axis, theta axis, and z-axis. So please make sure that you could remember this equation carefully. And this is the Navier-Stokes for theta axis, and this is the Navier-Stokes for z-axis. You could see that the term is become shorter here, and if you write, so this is the expanded version of Navier-Stokes for polar coordinate at z-axis. So this is the important notes for Navier-Stokes equation for polar coordinates, because in some textbook they will give you this kind of term. So please make sure. Sometimes in some textbook they will use 1 over r del over del r in bracket r del uz over dr, and it is equal to this term, and it is equal to this term. So, and then sometimes it will give you 1 over r del over del r, r del uz over del r, and it is equal to this one. Because sometimes in textbook, if this term is actually can be expanded into this one or into this one. So please make sure that we could write the Navier-Stokes equation for polar coordinates very well, because the term is a little bit longer compared to the Cartesian coordinates, and it is not enough for you just to remember the Navier-Stokes equation for r direction, because the value for z direction and theta direction is slightly different from the r direction.